Hello, chemistry students. Hopefully you've already watched the mole calculations video and the percent composition video because we're going to be building on that. And in those videos, we realized when we see H2O, we're really looking at this as a mole relationship. So in 1 mole of water molecules, we have 2 moles of hydrogen atoms and 1 mole of oxygen atoms. We also saw that we can calculate molar mass by using the periodic table and basically saying, okay, we have 2 hydrogen, 1 oxygen, we multiply 2 times 1.01, or 2 times 1 times 16. We basically get a contribution from hydrogen of 2, contribution from oxygen of 16 to get a total molar mass of roughly 18 grams per mole of hydrogen. We also discussed how we can use these mole ratios to convert to mass ratios or percent composition. So we could say, well, the percent of hydrogen in water, well, there's 2 grams of hydrogen per 18 grams of water. If I times that by 100, that will let me know that there's roughly 11.11% of hydrogen by mass in water. So the chemical formula is very useful. And we've learned earlier when we talked about compounds and expressing them through molecular formulas, we talked that the empirical formula is the simplest formula. So now we're going to apply that concept of determining the simplest formulas by using calculations and using our quantities. So that's what this topic's about. So given elemental mass percent data, we can figure out the formula of a compound. And this is actually really common. They do this in a lot of combustion analysis problems where they trap the carbon and they trap the water that is released in a combustion reaction and then weigh those amounts out to see how much carbon and hydrogen have been released in a combustion reaction. But often experiments will yield, these masses. And what we can do with these masses is, like I said, we can use them to determine an empirical formula. And again, an empirical formula, as a review, is the simplest formula. So, and if you watched my earlier videos, CH is a very simple formula. It's not a molecule, but it is the simplest formula. Now, the molecular formula is how the molecule is actually found. So CH is the empirical formula for, let's say, 2 molecular formulas of C2H2 and C6H6, right? If I divided acetylene, which is this structure, if I divided each carbon and hydrogen by 2, I would get this empirical formula, but it's not the molecule. Benzene, I'm just going to use a line formula, is that. And we see that every vertex is a carbon and there's a hydrogen bound. So there's 6 carbons and 6 hydrogens. So in any formula, subscripts represents the number of atoms of the given element, but we can also make that into mole ratios. That's what we talked about. So we can scale these up. So therefore, the subscripts can be interpreted as basically mole ratios. So to find an empirical formula, essentially is you're going to figure out the moles of each atom based on their mass, and then figure out a mole ratio. So once we have the masses, we can use molar mass from the periodic table. And then once we have the moles, we can do mole ratios to figure out the simplest ratio. So we want that because those mole ratios represent the subscripts in the formula. So you got to make sure that the subscripts are whole numbers, right? So you don't see, for example, HO 1/2. It's H2O. They're full integers. So here's an example calculation, right? I have a sample and it's decomposed and it produces 165 grams of carbon, 27.8 grams of hydrogen, and 220.2 grams of oxygen. Can I figure out the simplest ratio? So I like giving students a little table to help them. And you don't have to use this table. I just like it where you write out, all right, I'm going to put my elements here. I'm going to put the grams here, but remember, the formulas are not gram ratios, they're mole ratios. So then I'm going to put the moles right here because I'll convert grams to moles. And then once I have the moles, I want to find the simplest ratio, so I'll do a mole ratio. Okay, if I remember this table, now everything's gutted because I have carbon, I have hydrogen, and I have oxygen. They tell me for my carbon, there's 165 grams. My hydrogen, there's 27.8 grams. My oxygen, there's 220.2 grams. Okay, so now I have all my masses. What can I do? Convert those to moles. Why? Because the empirical formula is a mole ratio. And I can convert these grams to moles because I've learned about molar mass, right? So in 1 mole of carbon, there's 12.01 grams, periodic table. In 1 mole of hydrogen, there's, 1 gram. We'll just say 1 gram or 1.01 gram. And then for oxygen, there's 16 grams per 1 mole of oxygen. And when I calculate these values out, I basically get, like 13.75 moles of carbon out of 165 grams, 27.52 moles of hydrogen, and 13.76 moles of oxygen. Now, this isn't a simple formula, right? C 13.52, H 27.52. That, right? That's not simple. So how do I get the simplest ratio? Well, at least one of these elements should have one, just one. So I'm going to pick the smallest amount of moles and divide it into everything. So if I look, it appears that the 13.75 is smaller. So I'm going to divide everything by 13.75, 13.75, and 13.75. So when I divide the 13.75 moles of carbon by 13.75, I get a mole ratio of 1. When I divide the 27.52 moles of hydrogen by 13.75, I get a mole ratio of 2. When I divide the 13.6 moles of oxygen by 13.75, I get a mole ratio of 1. So what does that mean? It means my simplest empirical formula is CH2O. And now this is nice and clean, not hideous like that. And we want those clean whole numbers, those integers, to represent the simplest empirical formula. Well, what if I have this? I decompose a compound that has nitrogen and oxygen, and I find that it's 24.5 grams nitrogen and 70 grams of oxygen. So you can remember my table, right? So a lot of people don't teach the table, but it's basically you're going to get the elements, you're going to have their grams, you're going to convert their grams to moles using molar mass, and then you're going to get a mole ratio that's a whole number, right? That's what we're doing. It's that table. Now in the book, they don't always show you the table, right? But what are we doing here? We're taking the 24.5 grams of nitrogen and using molar mass to convert the grams to moles. So now we have moles. And I'm going to do the same thing for oxygen, right? I'm going to take my 70 grams of oxygen, right? That's my grams. And I'm going to convert it to moles. And how am I converting it to moles? Molar mass. And I get that many moles. So how am I going to get a mole ratio as whole numbers? Well, I don't want to write N 1.7504.38. So I pick the smaller of the two moles and I divide both by 1.75 in hopes of getting perfect whole numbers. Here's the thing, it doesn't always work out perfectly. So in this particular case, when I divide 1.75 by 1.75, I do get 1. But when I do the 4.38 divided by 1.75, I get 2.5. Now, those aren't perfect whole numbers. Not a problem. How can I make 2.5 into a whole number? Well, I can multiply both of these by 2. And when I do that, now I get the simplest ratio. N2O5. That is the empirical formula for this problem. So in some cases, you might have to multiply. So if it ends in a 1.33, you can think of that as 1 and a third. You're going to have to multiply it by 3. If it ends in a 0.25, like a 1.25 or a 2.25, you're going to have to multiply by 4 to get that 0.25, because 0.25 is like, a quarter, 1/4. So you multiply by 4, right? The 1.5 we saw, you multiply by 2. If you see a 1.66, that's like 2/3, and multiply by 3. If you see a 1.75, you're going to multiply by 4 because that's 3/4, and so on. But pretty straightforward. Elements. Once you get the grams, convert it to moles. Once you get the moles, find the smallest number of moles, divide it into all of it to get a mole ratio as simple as possible. If the mole ratio is not a whole number, you might have to multiply it to get it to be a whole number. In some cases, instead of them giving you grams directly, they'll give you percents. When they give you percents, just assume you have 100 grams and convert the percent straight to grams. So if they tell you you have 23 grams of 23% carbon, then just make that 23 grams. And you'll see that in our next video where we actually calculate not just the empirical formula, but the molecular formula as well. So I hope that helps, and thanks for tuning in.